Um, yeah, thank you so much, for, Helen, for the introduction and also the opportunity to visit your beautiful city. Thanks also to Jerry, along with Helen, for the invitation. This is our first time in Vancouver, and it's a great venue to be part of, and the event is timely, and the topic is important. So I'm going to come at it from the point of view of a designer, because that's what I am. I trained to be an architect, and so I don't have a technical background, and the perspective that we bring to any material is from a design perspective, how we can work with it, the constraints and the opportunities. So that's why I call it like a kind of ground-up approach to mass timber. We're excited by all the technology that's happening, like how can we participate as a design studio, as Helen mentioned. So I've been very fortunate in my 15-year career at Hadid Architects to have a very ringside view of some of the leading professional research and academic arenas when it comes to digital design and fabrication. And I started working at Zaha, as I said, 15 years ago, which we get a lot of professional opportunities to work on some of the most engaging spaces in the world. And at the same time, like I've been fortunate to work at, do my PhD at ETH in Zurich, which has been kind of leading in the last 10 years the front or the charge with robotic manufacturing and the corresponding digital design aspects and the computational engineering aspects as well. And at the same time, like I also like teach in the place that I did my master's degree called the AA, Architectural Association Design Research Lab, which is one of the world's only architecture focused universities. So there's no other discipline. It's been for 150 years focusing exclusively on architecture. So, so it's not much surprise that like a company that is exclusively focused on design, so we are 550 people, 500 of those are architects. For everything else, we collaborate, rendering, engineering, VR, everything else, like which is not architecture, we collaborate, and that's why we're in the heart of London. So we produce these kind of spaces, like which is an airport that got finished start to finish in about 4 years in Beijing in 2019, and in the same year we also completed this tower which has the world's tallest atrium. And so I was fortunate to see that, like, even though those buildings got completed in a very short time in 2019, the technological investment started already in the last decade, in 2009, 2010. So that's the perspective that I'm going to bring. Like, what is the role of design in promoting technology, and kind of bringing people together for a common purpose of creating something that is engaging for lots of people and lots of the users. So maybe I can start with a bit of blasphemy for a digital timber conference. I would like to kind of propose a few things that like digital timber could learn from digital concrete. What are those things? Oops. Yeah, so their digital concrete, like, or concrete in general, has similar issues as timber. Outside of the sustainability argument, is that, how do you promote design tooling that can support like some of these ambitions? They do have like a committee called Digital Concrete. And there's been extraordinary growth in interest in 3D concrete printing in the last decade, particularly in the last 6 or 7 years. But like like timber, they also lack a focus on the design parts. Like most exclusively almost, that like all of the interest, all of the research funding, all of the talents are being poured into material engineering, hardware engineering, rightfully so, for almost 3 decades. And of course, architectural design is relegated into the corner. And I would say like there's significant benefits to not ignoring design. One of the main things is that we can discover traditional wisdoms, like here we discovered that like we can incorporate like things from historic masonry, which are very much aligned with like concrete, because concrete is a material that wants to be used as an artificial stone. It is compression dominant, which is almost exactly like brick or stone. And also what we learned from masonry is curvature is beneficial, particularly a certain kind of curvature, like these kind of compression geometries. And secondly, like aligning material in these geometric patterns, like in the Nubian walls, are very closely aligned or can be adapted for 3D concrete printing. That's why you would see these layers of concrete are not horizontal, they're aligned with the force flow. And so we created this like with Block Research Group, like where I'm doing my PhD, and Zaha, the architects, we created this with Incremental 3D, which is a fabrication startup in Austria with maybe 3 or 4 people and like just 2 robots. We created alongside with Holcim Material Engineering, like start to finish, this project was about 6 months. Built to code and through passed through all the engineering requirements of building in Venice, which is an island. And so we also were able to demonstrate that the confluence of these 3 disciplines and designing geometry that is appropriate for the material, we can go a long way to achieve some of the sustainable development goals that digital concrete set itself out to, which is to reduce the amount of material, design repair-friendly footbridges and infrastructure. We can also reuse material because it is entirely dry assembled. There's no glue or mortar, so it can be disassembled and crushed easily, which has already happened. And it's also very recycle friendly because you don't have to separate the steel from the concrete and downcycle concrete. You can actually upcycle it, and so on and so on. So the key to all of that is that it is a digital material. And what do we mean by digital material, or why should we even care? Is because cynically, because in software is easier to scale than hardware. But more importantly, because material is getting scarce. Even timber is scarce. So we need to think of like any industry, any material industry, like the concrete industry, is waking up to the fact that it should not be a volume business. Your profit, it should not rely on selling large volumes of material, which is what the concrete business is currently. And so Holcim has recognized that, and they want to turn that into a value business, which means you need to attach it to software, right? Like so. And so, which is a kind of Tesla model, like they're not selling cars, they're selling a computer, which can be upgraded and so on. So it's that kind of sense that we want to bring to digital materials. Yeah, so, and what do we mean by digital material? Is digital design and manufacturing of shapes which are informed by material properties, which are material appropriate, and incorporates a certain structural logic and incorporates manufacturing and construction. So obviously it is closely aligned with DfMA or digital design for manufacturing and assembly. So I want to focus on the design part. And how do I keep? I think it's not working. Yeah. Yeah, so design, there's a prehistory to such design, like which is considering how things stand up, like, and how things can be made, and more importantly, also it's engaging. Like, so it's like Gaudi here did not try to sell the benefits of stone because it's digitally constructed, or it is considering manufacturing or technology of that time, like it is simply inspirational space to be in. And while at the same time it is fully engineered already at the time of design, he has considered how to assemble the stone, how to cut the stone, and so on. And at the same time, fully inheriting a bunch of things that like society at that time had developed, including like how to lay out, how to draw these shapes in the first place, and also how to construct it. Like, so they were like codified procedures on how to cut the timber, how to cut the stone, timber for the formwork, and the stone for the actual structure. and so on. And it was also, instrumentation was, like all the instruments at the bottom, it was available, like it was also codified in that sense. So we've been trying to adopt similar principles with computation, that how do you design the right shape for a given material and given structural logic. And so we've explored that with fabric. We explored that with robotic hot wire cutting and ruled surfaces. We explored that with curve crease origami and using robots to bend metal and sheet metal bending and so on, and also 3D printing, etc. So for the first decade of my time in Zaha, like we built like a bunch of prototypes like this, for which like I'm still eternally grateful that like Zaha was able to support such activity by attracting all the right people. And funding, of course. And as a consequence, in a very short time after her passing away, we were able to contribute to a large number of projects. And 2 of these are photographs, and like the top 2 rows are on their way to being photographs. And so that's the benefit of a digital material, because it is genuinely scalable. We are still a small team of 20 compared to the office of 500. But we contribute to a large number of projects in a year. So how do we digitalize the material? So by now, I hope it is clear that like we shouldn't question why we should digitalize, but we should think about how and how long and with who and how and so on. All right, so how do we digitalize the material? We should build design research. What do I mean by that? We should nurture ideas with students. We should shove aspirational images down every client's throat. We should delve into the history. We should propose some social use value, and definitely, most certainly, build an appealing pilot project, because you're never coming back from an unappealing pilot project. So yeah, we've been doing that with like Design Research Lab, working with a lot of graduate students, like exploring timber. What kind of language does it afford? What kind of tectonic capabilities does it afford? And how that is related to the manufacturing capacities. Like, does the layout of the factory actually affect the aesthetic? Which machines that you buy, like, does that affect the aesthetic, and so on? And we are kind of forcing students to investigate that relationship between the layout of the assembly line to what comes out. Like, of course, this is not as professional as a well-researched project, but like by engaging with nurturing like blue sky ideas, like getting people to think about these processes which architects normally wouldn't. We are beginning to encourage a lot of new talent that comes into studios like ours, or start their own practice, etc., to start thinking about the genuine opportunities for engaging, developing design with the corresponding technology. And yeah, we've been also proposing with like all of these competitions that we're doing, like this timber-only stadium in the UK, which we won, and it has been stuck in planning for a while. But we continue to do that. Like every project, like we try to propose aspirational buildings that like the clients actually want to build, and this is a similar project in Latin America. This is in Southeast Asia, and so on. So we've been trying to kind of really propose to the genuine value and explore, and not only propose, but explore what is the value of specific materials and specific construction types in a building. So here we are proposing a combination of modular construction with standard steel chassis, but we are also suggesting that like for high value spaces like co-living, co-working areas, where there's a lot of people, like we should use timber which is warm, has these qualities of which is very human and touch friendly, and the color is very engaging, and so on. So we propose this kind of mix of different material systems as well. We've also been working with a lot of research, both at researchers, collaborators, engineers. For example, at the ETH, where, as I said, I'm doing my PhD, with other timber suppliers in the region. And also considering like robotic assembly, what opportunities there are to convert that technical quality into a aesthetic. And we've also been looking at the history of timber construction, particularly in the UK, why you don't see any timber buildings at all in the UK now, even though there was like a prolific ecosystem of timber construction in a certain period. And it just fell out of fashion, even though there was like deep knowledge available. And we realized that like maybe timber's real competitor was not actually concrete, it was steel. And in perhaps there could be a design-motivated reason to bring back and work with timber again. And so we've been also developing these kind of experiments, like how can we do a rolled timber or developable sheets of plywood into formwork, and how that can actually lend itself to design experimentation and genuine impact on the spatial quality of spaces that we design. We've also been like looking at some of the scientific literature on how to design with timber, and like this is work from SOM architects who discovered a few interesting things of way back from the 19th century or 20th century, start of the 20th century, that for how that geometry is essentially required to limit to be economical with material. So if you want to minimize the amount of material, you want to be sustainable in that sense, it is all a function of designing the right shape. And so this idea, like, I mean, perhaps is very evident in the classic Mitchell trusses and so on. And a colleague of mine in ETH has fully extended this knowledge from the 20th century to fully 3D and fully designer compatible, right? Like, because it's very visual. And that's why we are very engaged with this kind of research, which is called graphic statics. Because it is graphical, because it is visual, because it is a common language that can unite not only designers but also architects and manufacturers. And that allows us to propose, like during competition stage already, these kind of structures like the lenticular truss that you see there. So it's not only the focus on engineering, but also the spatial quality, and it's also how we will construct it and so on. And that is also informed by, because designers don't really care for numerical analysis and so on. They want to know how to intuitively design these complex shapes. And so we also develop these simple procedures that are designer compatible, but they're definitely informed by some of the structural engineering logics and so on. And lastly, I want to end with a key message I started with, like all of this would not amount to anything unless we can develop an engaging pilot that genuinely shows the value of design to the end user and also the investor. And so that's what we've been doing for the last 4 years. We've been working with a startup city in Roatan in Honduras, where we are proposing a kind of high-density housing kind of combination of modular timber on top of concrete podiums, the classic 3/1 or 5/1. But like with a twist where we're trying to develop some of the design software which will adapt modular construction to terrain and the climate of the region, because and also the views that are on offer, because it is a beautiful island, and so on. So and make all of these parameters available to the end buyer. And more importantly, we are also trying to design for choice, where users can pick these pixels, and like based on which pixels are picked, we compute like an option for real time. It's a kind of car configurator, but at the scale of like a site. And also, go back. Yeah. And some of the ideas of Google and Katera and so on, like where we have a combinatorial possibility between a various standard kit of parts, also trying to design the kit of parts such a way that like there can be genuine surprise and it's not all monotonous the same. And trying to anticipate like what the users might need for a single family house or a multi-family house and so on. So yeah, we inherit a large number of the ideas of digital timber or mass timber, standard kit of parts, library of parts, which are already engineered and so on. One thing that we wanted to do differently on the island is to go with this idea of a micro factory as opposed to a gigafactory, whereby we start small and we import like just 1 or 2 robots and work with the local building trades and digitize them. So it's a kind of low capital investment approach for the first 10, 15, 20 houses before which we can scale up. But already that is allowing us to incorporate all of this information of how raw material gets converted into a house, into a so-called configurator, which we built using a game engine. Not a CAD platform, but the Unreal game engine, because it is gamifying one of the most important investments any family makes. And so it's trying to be as transparent as possible so that like what they see is hopefully what they will get as quickly as possible as well. But what's interesting is that they not only can customize their house, interior of it, but they can also pick the site, like in 3D space. And then we as architects come and try and negotiate or resolve conflicts between people who made the same choice. So that kind of de-risks things for the buyer in the sense that it is as transparent. So there's not, so we are trying to gamify and make intuitive one of the important decisions, financial decisions anybody can make. And it's also, the reason we're using a game engine is it's photorealistic, and so it's more directly intuitive to the end buyer what they're getting. And second, it's also de-risking it for the developer because they're assured buyers, and potentially you could then also do dynamic pricing if there are more people demanding a two-bedroom house versus a single-bedroom house and so on. In this particular instance, we haven't because it's a pilot project. And also we already know which ones are more popular. Like you don't have to design 20 different types to the greatest of detail and then find out that only 2 of them are popular. So we're kind of front-loading the process, and that kind of de-risks things for architects and suppliers as well, because there is a definitive spec sheet that we can have. And more importantly, one of the key benefits we found was that by having this kind of gamified approach, like we can optimize things beyond the single unit. We can optimize at the level of the stack. For example, at the bottom, houses can have more structural material than the houses on the top, which can lead to significant material savings. So that's where we are at. We're hoping to finish this pilot project of 10 houses in summer of next year, and hopefully pave the way for a more denser and vibrant community. And to conclude, digital timber, we proposing, positing that like the D in DfMA is always the bottleneck, and we should encourage as many architects and designers to participate and come up with new designs, because once you promote that, everything else follows, because the common language of visual geometrical language like promotes collaborative problem solving. It can then promote economical use of material. It can make durable construction possible, and so on. It can also return a vocational pride to something that is beginning to be very missing in the building industry. And if anything, if we can learn anything from the automobile industry, I think it should be about not automation and not about assembly line. It should be about creating engaging and responsible buildings. Engaging meaning like that it is not only about high performance, but it is something that people want. Like so it's not about the assembly line as Ford kind of made popular. Not only that, that is important, but also recognizing that the significant success of the car industry is positioning the car as singularly important to your lifestyle of the 20th century. So that's what was, we believe, the success of the car industry is that like they were able to bring these two things together, the assembly line, but also a significant lifestyle change that convinced a lot of governments and people. And so we want to try and do that ground up to position responsible green lifestyle as important in the 21st century. So thank you for your attention, and I'm open to any questions.
So do we have any questions from the floor? Jerry? Any from online?
Not right now.
Okay. I have to say, Shajay, that is probably the most stunning 5-on-1 configuration for a mid-rise residential project than I have ever seen. It really goes to show that, you know, design is absolutely what underpins everything. One question I have for you, though, is how do you get your clients to kind of buy into your vision? I mean, you know, these are pilot projects, they're research driven. Maybe you can just fill in some gaps for me there.
Mm-hmm. Yeah, I think that it's an important thing to realize that like for every project that gets built, like we propose at least 20. And most of our work, it's not is not like repeat clients who just come to us because we are Hadid architects. We win our work by competing, and so we do at least every month, like we do at least 20 competitions in a firm of 500. So that means like we are like very optimized to experiment a lot, like, and so we are just increasing the probability that one of the clients is gonna want one of these. But at the same time, because we iterate so quickly, we are also refining the idea. Like if it didn't work the first time, it's not gonna work the second time if we just keep the same idea. So we just iteratively and evolve the idea little by little. And so eventually, you know, 10 years later, like a client might buy it, or 5 years later, like it will click. And so that's, I think, one of the key messages is that it's not just, we're not leaving it to chance. We're trying to improve the probability of success by just doing more. Like, so our business is built around doing a lot of competitions. And so that's why we use technology in the way we do. Like we borrow from the gaming industry, we borrow from other industries heavily, because making movies is very similar to making buildings, because you have to iterate a lot of times to get the movie correct. Like it's not that somebody had one idea one day and then it's just like the next 2 years people are just iterating or executing somebody's idea. It's just everything is evolving collaboratively. A typical movie probably, you know, has 300, 400 people working collaboratively. And so we think, which is something that we have kind of discovered working in China, because they build faster than we can design, and that's also something that they have evolved the capacity for. Yeah, so that, I think that's the gist of it. Like we don't convince clients just because we are Hadid architects, but we convince them because we have done so many iterations of. So we genuinely convince them of the value of design. Yeah.
Hey, yeah, quick question for you. So you guys are obviously doing lots and lots of iteration, many different projects very quickly. How do you make sure that you're efficiently taking the tools? Because obviously every project is kind of a one-off. How are you making like a consistent set of tools that you can take from project to project to project and see that efficiency? I
would say we're not looking for efficiency. in the use of software. So I mean that kind of distinguishes us from many of the other computationally oriented or digitally oriented companies, is that we want to use technology to increase the market value of our designs, meaning the market price of every square meter that we design should go up because of the technology that we use. And so it should be evident to the end user why they should pay more, right? That's why I said Tesla, like a lot of technology goes into it, but it's not about efficiency. It's about like increasing the market value because you want to sell if you want to sell a value business or you want to be a value-oriented business, like then, you have to educate and convince the clients about the value of the design and the digital components. So we're not saying that our buildings are inefficient. That's the engineering concern. Like that's why we collaborate with all the best engineers in the world. But what we want to do is use technology to bring design value into the world. I mean, put it crudely, we make technology look good. Yeah.
Awesome. Thanks so much.
Yeah.
Can you go to the microphone? Yeah.
Congratulations on the work. That's great. Thank you for sharing and coming.
Sure.
Going to ask a classic question, I think, for digital fabrication discussions in general is the top-down, bottom-up combination. So, it's obvious that the inputs are leading to an output through the aid of a lot of the technology that you have. What is the role of the kind of top-down calibration, the culture, the kind of higher-level design that isn't necessarily so easily outputted, that might shape an architecture that is not necessarily always just being a straight output from the technology, from the computer, from those kinds of engines?
Yeah, that's a great question, and that again, like with why we are interested in the movie making industry and the storytelling industry is they use a lot of high-level, high-performance technologies, but to the end of telling stories and communication, right? By telling stories, I mean to communicate something, and so that's a very human thing, right? Like it's a human skill, and you can be augmented through digital means, and that's our position of using technology. Is not that like we want to have generative design in the sense that you click a button and you see thousands of options and then you pick. Your role as a designer is not to pick the best performing one, but like using technology to iterate and so we think of it as augmented cyborgs, right? Like, so we can augment the human designer or design team, because it's collaborative always, with the thousands of hours of computation, whether it's AI, which learns from history and or even if it's like kind of decision support technologies and so on. So we believe in this edit and observe type of paradigm of CAD technologies, which is what like the movie industry is very famous for, right? They always privilege real-time performance. So which means if a designer moves something, they see immediate feedback. Like it's not like you move something and wait for 2 hours for the simulation to finish, which routinely happens in the building industry because the simulations are so complex. And so we say like, okay, we are not interested in like the super detailed simulation. We're happy with the kind of 80% solution, because at the early phase of design, like you don't need to know exact, carbon footprint, exact like everything. You need to work with first principles. And that's where we look a lot at historic precedents who did a lot of amazing buildings with zero computers, right? Like, so that's our position. Like, we want to privilege iteration, and anything that encourages rapid iteration, multiple iterations, so we believe in this kind of evolutionary model. So any competition, it's not just one designer. There are actually 2 or 3 design teams, each with 3 people on. So early on, like in a competition, there are 10 options. And then they get whittled down to 3 and 4, and like then in all of this, that's the kind of technological investments we are making, is to improve design iterations. So that that obviously means as it's going to reflect on the product. Our designs are going to inherit these rapid iterations, which is like the Pixar model, actually, right? Like all of their technologies cater towards the storytelling.